Watching a welder at work is almost hypnotic. He works with calm precision as sparks fly all around him. But did you know that these sparks are actually small pieces of molten metal that break off during cutting and welding while working with blowtorches? How do these blowtorches work? Let's find out in today's episode. Welcome to the sparkling world of chemistry. I am Devabrata Goswami and today I will introduce you to the world of alkynes. In this episode, we will talk about their nomenclature, structure, nature and their method of preparation. And as usual, after we are done with the learning, we will tackle this topic from the exam point of view in the exam decoded section. Some of the best friendships begin with a simple introduction. So, what are alkynes? Let's find out. Alkynes are unsaturated hydrocarbons which contain at least one carbon-to-carbon triple bond. Alkanes have a single bond. Alkenes have a double bond. And alkynes have a triple bond. That much you know. Alkynes have the general formula CnH2n-2, where N denotes the number of carbon atoms. So, the formula of the alkyne with two carbon atoms is C2H4-2. That makes it C2H2. The first alkyne is acetylene. Similarly, the alkyne with three carbon atoms is C3H4 and it is called propylene. Remember, in the beginning of the show, I had told you about blowtorches used in welding. Now, let's find out what connection do they have with what we are studying today. In these torches, acetylene is burnt in pure oxygen. This combustion of acetylene with oxygen produces a flame of over 3300 degrees Celsius and releases 11.8 kilojoules per gram of energy. The temperature is high enough to melt most metals. Interesting, right? Now that you know what alkynes are, let's see how they are named. Take a look at your screen. The first step is to find the longest chain of carbon containing carbon-to-carbon triple bond. This will give you the word root. The next step is to number the chain in such a way that the triple bond is on the carbon with the lowest number. The name of the alkyne is written as word root with a suffix YNE. Well, now let's understand this better with an example. Let's try and name this compound following the steps we just discussed. In this compound, the longest chain has 5 carbons. So, the prefix pent will come here. Now, this chain can be numbered from left to right or from right to left. Which one is correct? In the first case, the carbon with the triple bond is number 2 and in the second case, it is number 3. Therefore, numbering from right to left is correct. This gives us the name of the compound, pent2I. Easy, right? But wait, what will you do if there exists a double bond in the chain as well? Let's figure out with the help of an example. Let's consider another compound. When we number it from right to left, the double bond is on carbon number 1 and triple bond is on carbon number 4. When we number from left to right, the triple bond is on carbon number 1 but the double bond is on carbon number 4. As I said before, double bonds take priority over triple bonds. So as you can see, the name of the compound on your screen is pent1ene4ine. For more practice in naming organic compounds, you can log on to www.topperlearning.com. Interesting as it is to name compounds, it is time to take a break. And here is your break question. Do you know which scientist discovered acetylene? Keep thinking, but come back fast to know the answer to this question and to understand isomerism. Welcome back. I am Devabrata Goswami and you are watching Chemistry 11. Before the break, we understood what alkynes are and how they are named. There is more to that, but before we move ahead, here is the answer to the question I asked before the break. The question was, which scientist discovered acetylene? Well, acetylene was discovered in 1836 by Edmond Davy. It was rediscovered in 1860 by French chemist Marcelin Berthelot, who coined the name acetylene. It is time to move ahead now, and as I promised, we will be talking about isomerism. Well, alkynes show position isomerism. Recall that two or more compounds having the same molecular formula but differing in the position of substituent atom or functional group on the carbon skeleton are called position isomers. Confused? Let me explain with the help of an example. Let's take butane and understand the concept of position isomerism. Take a look at the picture on your screen. In this case, there are two possible position isomers, but1-ine, in which the position of the triple bond is between the first and the second carbon, and but2-ine, in which the position of the triple bond is between the second and the third carbon. Since both the compounds have the same molecular formula and they differ in the position of the triple bond, they are position isomers. So now you know how to name alkynes. Let us now understand the structure of alkynes. As you can see, in ethine, the carbons of the triple bond are sp hybridized. Out of the two sp hybrid orbitals on the carbon atom, one overlaps with the 1s orbital of H, forming a sigma bond. The other sp hybrid orbital overlaps with sp hybrid orbital of neighboring carbon, forming another sigma bond. The unhybridized 2px and 2py orbitals form two pi bonds. The HC triple bond C bond angle is 180 degrees. Now, since the carbon of the triple bond is sp hybridized, terminal alkynes are acidic in nature. Let's study this in detail. See, the sp hybridized carbon has maximum S character, that is 50% S character and 50% P character. Due to greater S character, the electrons are closer to the nucleus. So, the electronegativity of sp hybridized orbital is the highest. This will lead to the shifting of shared pair of electron pair of the CH bond towards carbon. The hydrogen atoms can be liberated as protons. This is why hydrogen atoms of ethine attached to triply bonded carbon atom are acidic in nature. Here, you must keep in mind one thing. The hydrogen atoms attached to the triply bonded carbons are acidic and not the hydrogen atom present on other carbon atoms. For example, in propyne, the hydrogen attached to methyl group are not acidic, but that attached to triply bonded carbon are acidic. Let us understand the acidic nature of alkynes in depth. Take a look at the reaction of ethyne with sodium metal. When ethyne reacts with sodium metal, it forms sodium ethynite, a salt, and liberates hydrogen gas. This reaction is a typical test for acids. Now that you know the nature of alkynes, let's move on to the last topic for the day, the methods of preparation of alkynes. On an industrial scale, ethyne is prepared by treating calcium carbide with water. Take a good look at the apparatus first. A dropping funnel is attached to a conical flask which contains calcium carbide. Also attached to this flask is a glass tube which connects it to a container of water. An inverted glass jar is placed over the beehive shelf placed inside the water container. Now pay attention to the experiment. See what happens to the small pieces of calcium carbide taken in a conical flask when water is slowly dropped on it. Calcium carbide reacts with water to give ethyne gas. As you can see, this gas is collected by downward displacement of water. This is because it is insoluble in water. I hope this method was clear to you. If you want notes to supplement your learning, you can always log on to www.topperlearning.com for help. Before we go on to the other method of preparing alkynes, I want to tell you why knowing this is so important. In late 19th century, bicycles often had solid tires with acetylene lamps up front and a tool roll strapped to the underside of the crossbar. The question is, how did these lamps work without batteries? Well, these were lamps also called carbide lamps or acetylene gas lamps. They are simple lamps that produce and burn acetylene. Acetylene is produced by the reaction of calcium carbide with water. The upper compartment of these lamps contain water which drips into the calcium carbide present in the lower compartment, and the acetylene produced burns at the jet. These acetylene lamps were once as common as headlights on cars and bicycles. These lamps were also used in mines. Carbide lamps were also used to illuminate buildings as lighthouse beacons and are still employed by cavers, hunters, and cataphiles. Now, let's move on to the next method. The next method used to prepare alkynes is from vicinal dihalides. Here you must recall that vicinal dihalides are those halides in which the halide atom is present on the adjacent carbons. These vicinal dihalides are reacted with alcoholic potassium hydroxide, and this dehydrohalogenation reaction takes place in presence of alcoholic potassium hydroxide. What happens is that one molecule of hydrogen halide is eliminated to form an alkynyl halide. Now, to remove a second HX molecule, we need a very strong base, for example, sodamide, and high temperature. What we get at the end of the whole process is an alkyne. I know that questions must be bubbling in your mind. So let's take this call from a viewer who has a question.
Hello sir, my name is Kirti and my question is, do alkynes also exhibit cis-trans isomerism?
Good question, I must say. Well, the answer is no. Cis-trans isomerism is a form of stereoisomerism describing the orientation of functional groups within a molecule. Generally, compounds containing double bonds show this type of isomerism. This type of isomerism is due to a restricted rotation around the carbon-carbon double bond. As a result, the position of groups attached to these carbons is fixed in space. alkynes do not show cis-trans isomerism because there is no restricted rotation in alkynes. This is because alkynes are linear. I hope this topic is now clear to you. It is very important that you do not just memorize the reactions without understanding them. Another thing, be careful of the double and triple bonds. Don't worry if you missed anything. You can just log on to our website www.topperlearning.com to refresh your learnings. It's time for a short break. Keep thinking and stay tuned because coming up on the other side of the break is Exam Decoded. Welcome back. I am Devabrata Goswami and you are watching Chemistry. Before the break, we were studying about alkynes. If you missed out on some points, here is a quick recap of what we learned. Alkynes are unsaturated hydrocarbons containing at least one carbon-to-carbon triple bond. They have the general formula CnH2n-2. The presence of sp hybridized carbons is characteristic for alkynes. Hydrogen atoms of ethyne attached to triply bonded carbon atom are acidic in nature. Now that this topic has been refreshed in your memory, let's move on to my favorite part of the show, the Exam Decoded section. Welcome to Exam Decoded. I know you all have been gearing up for the rapid fire. Well, before you get going, here are the rules. I will ask you 5 questions and you will get only 5 seconds to answer each. And give yourself 1 mark for each correct answer. Ready? Here we go. Question 1. The general formula of alkynes is A. CnH2n, B. CnH2n plus 2, C. CnH2n minus 2, D. CnH2n minus 1. And the correct answer is C. CnH2n minus 2. Here is the next one. The carbon atoms of the triple bond in an alkyne are A. sp hybridized, B. sp2 hybridized, C. sp3 hybridized, D. sp3d hybridized. The answer is A. sp hybridized. Moving on to the third one. The simplest alkyne is A. Ethyne, B. Propyne, C. Butene, D. Pentine. You know this one, don't you? Well, the answer is A. Ethyne. Here comes the fourth question. Hydrogen atoms of ethyne attached to triply bonded carbon atom are acidic in nature. True or false? Well, the answer is true. Take a deep breath. Here comes the last question. The formula of ethyne is C2H2. True or false? It's true. That was easy, wasn't it? Now, it's assessment time. If you got 5 on 5, here is a high five from my side because you are a high flyer. If you got just one wrong, you got to pay a bit more attention, but nevertheless, you are an achiever. But if you got 3 or below, you got to pull your socks up as you are still a learner. But don't worry, www.topperlearning.com is always there to help you. Now that the chapter is at the back of your hand, it would be wise to know what is tested. Alkynes is from the topic hydrocarbons and carries the weightage 8 marks. So it's critical from exam point of view. Usually, short answer questions worth 2 to 3 marks are asked. And these questions will test your knowledge and conceptual ability. Now that you know the topic well, and that you know the answers too, the only thing that can stop you from scoring 10% is presentation. But soon, that will not be a problem too. Time to figure out the ideal answer for a probable question. Pay close attention as presentation is the key for full marks. Your question is, explain what the order of acidic behavior of the following compounds is, with reasons. Ethyne, ethene, and ethane. This question can come in your exams for 2 marks. Here is how to get both these marks. You must write the increasing order of acidic behavior is ethane is less acidic than ethene, which is less than ethyne. You get 1 mark for writing this. The reason for this is that in the first compound, the carbon is sp3 hybridized. In the second compound, carbon forming the double bond is sp2 hybridized. And in the third structure, carbon forming the triple bond is sp hybridized. Now we know that the more the S character of the carbon, the more is the electronegativity. Eventually, more electron density is drawn towards the carbon. This will lead to increase in acidic character. The reasoning gets you the remaining 1 mark. Make sure your answer is framed in a similar manner and the reasons are stated clearly with appropriate reactions wherever required, and you will max this topic. This is a relatively easy topic, so make sure you know it like the back of your hand. Time to go now, but before I leave, here is something for you to think about. We have seen how acetylene burns in pure oxygen, producing very high temperatures. In air, however, acetylene burns with a sooty flame. Why? Well, this is due to higher amount of carbon in ethyne. All the carbon atoms do not get oxidized while burning, and this makes the flame sooty. I hope you learned a lot from today's episode. Do log on to www.topperlearning.com for more such brain-tingling questions and thirst-quenching answers. Remember, curiosity and thinking is the route to success. So keep thinking and best of luck. Meet you again with another episode of Chemistry.